Now let's talk about functions. A function is a container just like a struct, only a function container holds instructions for the computer to perform instead of just data like a struct. A function is a handy way of grouping together bits of code that are done over and over, or a chunk of code that you want to be able to easily share in several different programs. For example, let's say your shader has the ability to adjust the brightness and contrast of the final output color. You could group the instructions to do that together in a function. So let's go ahead and write a brightness and contrast function so you can get the idea of how functions work. First thing that we're going to do is get rid of this sample struct code. And then, so first of all, just like a struct, you have to define the function first before you can use it. To define a function, first you specify what type of data the function is going to give you as an end result. In our case, the brightness and contrast function is going to give us a color as an end result. So we'll start with float3, because that's the color, and we'll call our function brightness contrast. And we'll put two brackets, or parentheses, rather, and end with a semicolon. Also notice that I've given the function a name, brightness contrast, and so next we're going to tell the function what data it's going to use as inputs. The input data is going to go between the parentheses right here. So first we're going to need a color to start out with, and we'll call it start color. So we'll say float3 start color. Next we'll need the amount of contrast. So we'll say float contrast amount. And finally, we need the brightness amount. So we'll say float brightness amount. So now that we have our function's inputs defined, let's create the actual code that the function will perform. When defining a function, code always goes between curly braces, like this. First, we're going to create the start and end code, then fill in the meat in the middle. Common practice when writing functions is to create a value at the beginning, modify the value, and then output the value at the end. So let's create a value and return it. We'll say float3 result, and the function always ends with return result. Function always ends with the word return, so the computer knows what the final result of the function is. Our function works now, so I could use it if I wanted to, but it doesn't do anything yet. So let's put in the math that does the actual brightness and contrast. We're going to say result equals start color minus 0.5. So we'll take the first color coming in and subtract 0.5. Then we'll take the result of that. Result equals, actually we're going to say result times equals, result times equals contrast amount. Then result plus equals 0.5. And then result plus equals brightness amount. Okay, so there's our function. Now what's happening here? Well, first of all, we take the color that we're starting with and we subtract 0.5. So basically we're taking the brightness down by half. And then we take the result of this line And times equals means we multiply this times this to get our result. So half of our original color value times our contrast amount. And then we take the results of that and we add 0.5 back. So we subtract 0.5, multiply by our contrast amount, and then add our 0.5 back. This function, or this bit of code, is what gives us our contrast. And then for brightness, all we have to do is add in brightness amount. All right, so there's our finished function. One thing that I should probably tell you is that you can't define a function like this inside the vertex shader or the pixel shader. So I'm just going to go ahead and cut this piece of code, and I'm going to paste it up here outside the vertex shader. So we have our function defined in the area just above the vertex shader. So now that we have a working function, let's use it. So here's how you call the function. I'm going to say float3 result equals float3 0.5, 0.5, 0.5. Now I'm going to say out.color equals float4 result and 1. And I got an error because I forgot to put my semicolon here. So we'll put a semicolon in, save it. So now my output color is gray. You can see when I come over here to max, it updates my teapot, the gray color. So now I want to modify that value with my brightness contrast function. Before I do that, I just want to point out one thing right here. I want to make this really clear. Out.color, this member of my output struct up here, output to pixel shader, the struct, is a float4. Notice that? So down here, when I say out.color, I have to give it a float4. Now I've created this value called result, but result is just a float3. So right here, what I'm doing is converting result from a float3 into a float4 by making a new float4, putting result in the first slot, and then 0.1 in the second slot. So I've taken my float3 result and added one more component to it to make it a float4. And that way it'll fit in out.color, which needs to be a float4. Okay, so now we'll call our brightness contrast function, and we'll do that like this. I'm going to say result equals brightness contrast, call the function by name, and then I'll put some parentheses and fill in the values. Now, what I'm doing here when I'm filling in the values is whatever values up here in my function, so I need a start color, I need a contrast amount, and I need a brightness amount. So here when I call the function, brightness contrast, I need to put in a start color, and my start color is going to be result, right? And I need a contrast amount. In this case, we're just going to make the contrast 0. And I need a brightness amount, so we're going to say 0.5. Now let's take these values and look up here in our function and see what's going to happen. So the result value that I've passed in becomes the start color. So start color minus 0.5. And my start color is 0.5, 0.5, 0.5, remember? So if I subtract 0.5, now my value is going to be 0. I'm going to multiply it by the contrast amount, which is 0. Then I'm going to add 0.5. So my result up to this point is going to be 0.5 because I had 0. Now I'm adding 0.5 to it. Then in this line, I'm adding the brightness amount. And the brightness amount that I've passed into my function 0.5. So this brightness amount gets sent up here into here, and then in the function it gets used right here. So I add that to the result. So can you see what the final result's going to be? 0.5 plus 0.5. My final result is going to be 1. What that means is my resulting color is going to be white. So assuming I didn't do anything wrong, hit save here, and my teapot should turn white. Yep, there we go. So I called my function, and I passed in the values that it wanted, and it gave me back the results of the function. So this is how you tell the computer that you want to run the code that's contained in the function. You call it by name, and then you pass it the values that it requires. If I never called this function by name, if I never said brightness contrast, this little bit of code here would never run. But since in my vertex shader here, I've said brightness contrast and then given it the values that it wants, once the computer is stepping through the code, once it gets to this point, it's going to go, oh, I know the name of this function. I need to go back up here, fill these values in, and run this code on it, and then return whatever the result is. Now these names are kind of arbitrary here, so I could rename this Ted if I wanted to, and then I could return Ted. And down here for result, I could call result Joe Bob, right? And Joe Bob, and then return Joe Bob. And that's going to be exactly the same. What I wanted to show you that, whoops, it didn't quite work. No. So if I create float Ted here, I have to call him all Ted. Like that. And then I have to call this one Joe Bob. And then it'll work. So the names don't really matter. And it's best to give your data types and your structs and your components names that make sense. So in this case, Joe Bob doesn't really make sense because it's really a color. And so I'm going to call it color instead. Actually, I'm going to call it diffuse color. And then I'm going to call this result. So the result of the, no, I need to call it diffuse color actually, because I haven't defined result. So diffuse color, and pass that out, save. So there we go. I'm using some names that make a little bit more sense. Anyway, so that's how a function works. You can set up a chunk of code and define the inputs here, and then define the outputs, whatever it is that it returns. And then you can call the function in your shader anytime you want. Just to show you how fundamental functions are, notice here that the vertex shader is a function, right? And it's taking app to vertex in as its input. Now, app to vertex in is this struct. So the input of the vertex shader function is app to vertex in. So my whole vertex shader is actually just a function. And it doesn't get called until down here at the bottom where it says techniques. I'm calling my vertex shader right here. Same thing with the pixel shader. The pixel shader here is pulling in vertex to pixel in, which is my output from my vertex shader input to my pixel shader struct. And then it's returning a color, a float 4. So functions are pretty much fundamental to the way shaders work because both the vertex shader and the pixel shader are functions which are called at the bottom. So really, when the computer looks at a shader, it's going to read through like this. It's going to read this line. It's going to see these struct definitions. And then to actually execute code, it's going to jump all the way down here to the technique and go, oh, I need to run this function. So then it's going to jump back up here and run the vertex shader function. When it gets to this point, it's going to say, oh, I need to run this function. So then it's going to jump up to here and run this bit. Then it'll go back down here and continue, and it'll say, oh, now I need to run this function. So then it'll jump up and run the pixel shader. So you can see that functions kind of define the flow of the code, or where the computer is going next. Now, in terms of structure of the shader, in terms of like what techniques are and things like that, we're going to get into that in the next chapter. I've kind of breezed over a lot of these things, like I haven't talked about this part yet. But in the next chapter, we're going to talk about the structure of the shader itself. So we've covered some of the basic building blocks of a shader. The data types, float 3s, float 4s, for example, that hold our data. The structs, right here, that contain groups of data, and also functions that contain instructions to perform on that data. Along the way, we've even made some sample shaders. And so far, we've only been working right here in this one little spot inside the vertex shader. In the next chapter, we'll go over each of the components that make up the whole effects framework and discuss all of the elements that come together in the complete effects package.